Dear students, greetings of the day. Today we will discuss about the complete intersection execution in a single bus system. The diagram shows single bus system. Here there are various components available. We will see one by one. This is the common bus single bus system. We already introduced what I mean by a single bus. That is, it is a group of wire. It contains a group of wires. It will transfer the data from one place to another place. It is a common bus for all the operations. PC is nothing but program counter. Program counter always holds the address of the next executable instruction. MAR is nothing but memory address registers. It holds some address. Normally that address during next cycle, it will access the address from the memory and store the either instruction or data into the MDR. The MAR and MDR are the two units. They are directly connected with the memory. For any memory related operations, we can perform via either MAR or MDR. Normally, address operations are performed via MAR and the data operations are performed via MDR. MDR is nothing but memory data register. Here in right side, instruction decode and control logic is available. That will do the decoding and execution operation based on the control logic. Below that, IR instruction register. The instruction register holds some instructions. An instruction contains a group of bits. Normally, it contains mode bit, opcode, and the address part. Based on the opcode, some operation to be performed by the CPU. The address part contains data of the address or sometimes immediate operand. Y and Z and temp are the three temporary registers available in this common bus system. The R0 to Rn-1 is a group of general purpose registers. The MUX is nothing but multiplexer. The inputs for the MUX are constant 4 and the output of the Y. Based on the select line, either one of the input is forwarded to the output. ALU contains two inputs and one output. One input from the common bus system and another input from the multiplexer. And the ALU gives the output to the temporal register Z. So Z contains Z in line and Z out line. These are the general organization of the single bus system. We note that MDR contains two inputs and two outputs. We'll take one example of add within bracket R3, R1, which means we have to perform the add operation between the operands available at the R1 register and within bracket R3 means R3 contains some address, memory address. In that memory address, actual operand is available. We have to fetch that data from the memory indicated by the R3 register and we perform the addition operation already with the available value of R1. That is our aim. That is, you have to perform the addition operation between the value of R1 and the value of R3 that is available in the memory. For that, what are the operations needed? We have to see one by one. First, as I told earlier, PC contains the address of the next executable instruction. So we have to bring the PC address onto the common bus system. That is forwarded to the MAR. MAR initiates the read cycle. At the same time, we have to select the 4 in the multiplexer. Already this PC value available via this common bus system into B. You will add the current value of the PC with the value of 4 via MUX. By the way, we can get the next executable address that is forwarded to the Z register via Z in and Z out. That value goes to Y in, also into the PC. That is indicated here. That is PC out. We will take the PC value, transfer into the MAR and initiates the read cycle. Select 4 in the MUX multiplexer and add with the previous content of PC and transfer that content into Z in. These 6 operations are held in parallel in cycle 1. After that, in cycle 2, Z out, that is, it will forward the Z in value onto the common bus that goes into the PC as well as Y in and initiate, and we have to wait for the memory function to be completed. WMFC means wait for memory function to be completed. Then after some time, few seconds, the MDR out. MDR contains the instruction fetched from the memory that will be transferred to the IR in via common bus system. Then already we have the data address in R3. So R3 out to be taken from the register on the right side and paste it onto the common bus system. That is forwarded to the MAR. This MAR in. Then you have to initiate the read cycle. R1 contains the actual data because the instruction indicates R1 contains the actual data. So that is forwarded into the common bus system and that will go to the Y in via this common bus system. Then we will initiate we have to wait for the memory function to be completed because we already initiate the read cycle in the previous clock. Then after getting the data into the MDR from the memory, we have to select the Y. That data is via common bus system forward to the Y. Already we have the data of R1 in the ALU via this common bus system. So now we have the data of R1 and R2, both A and B of ALU. Then we perform the add operation. Then you have to transfer the result onto the Z in and the Z out, transfer the results and again store it onto the R1 register available on the right side. Okay. So this is the execution of a complete instruction to the help of a single bus system. I hope you understand the concept. Thank you.